You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. A flowchart is a diagram that represents the logical structure of a process, typically a computer program. It uses visual symbols to depict operations, decisions, and the order of execution. Flowcharts are used in both programming and system design to clarify how tasks are organized and how decisions influence the outcome. This tool helps programmers, analysts, and learners visualize the logic that drives a process, often before any code is written. Standard flowchart symbols are used to communicate the function of each step in a program. The oval shape marks the start or end of a process. A rectangle is used to indicate a specific action or operation, such as assigning a value or displaying text. A diamond shape represents a decision point, where the program must evaluate a condition and proceed based on whether it is true or false. These symbols are universally recognized in flowchart design. The direction in which a flowchart proceeds is shown by arrows. These arrows link the various symbols together and indicate the sequence in which steps occur. Typically, flowcharts move from top to bottom, but they can also move from left to right. When decisions are present, arrows split from the diamond shape and branch to different outcomes. These paths reflect how a program responds dynamically to varying inputs and conditions. Programming begins with the concept of sequence, which refers to executing commands one after the other in the order they are written. A sequence does not involve any decision-making or repetition. Each instruction completes before the next one begins. For example, a sequence might consist of 3 actions: displaying a welcome message, asking the user to enter their name, and then greeting the user using their input. These steps occur linearly and without deviation. Decision structures introduce branching into program logic. A decision requires evaluating a condition and selecting one of 2 or more paths based on whether that condition is true or false. These structures commonly use if-then or if-else formats. For instance, a program may check if a user's age is greater than 18. If true, access is granted. If false, access is denied. In flowcharts, decision points are represented by diamonds that split into different paths. Loops allow for the repetition of a block of code as long as a specific condition remains true. This repetition helps programs handle repetitive tasks efficiently. 2 common types of loops are the for loop and the while loop. A for loop repeats a fixed number of times, while a while loop continues indefinitely until a condition changes. In flowcharts, loops are shown by an arrow looping back to an earlier step in the diagram, typically from the bottom of a process box to a decision point. Logical operators are tools used to evaluate conditions within decisions and loops. The AND operator requires both conditions to be true to proceed. The OR operator allows the program to proceed if at least one condition is true. The NOT operator inverts a Boolean value, turning true into false and vice versa. These operators allow for complex conditions to be evaluated with simple logical combinations. They are foundational in conditional logic and loop control. Boolean logic plays a central role in programming decisions and looping behavior. A Boolean expression is any condition that evaluates to either true or false. In a decision structure, the path taken depends entirely on the outcome of a Boolean expression. For instance, a check for whether a number is less than 10 might return true, and the program would proceed accordingly. These true or false evaluations are at the heart of all control structures in programming. Flowcharts show exactly how Boolean logic affects a program's flow. A decision diamond might evaluate a Boolean expression, and depending on whether the result is true or false, the program follows a different path. This could result in different outputs, repeated steps, or terminated processes. Flowcharts make it easier to trace these decisions visually, making them a helpful learning tool in both programming and system design. Loops often rely on Boolean logic to determine when to continue and when to stop. For example, a while loop may continue running as long as a variable remains less than 5. Once that condition becomes false, the loop exits and the program moves on. This combination of Boolean evaluation and structured repetition is the core of automated processing in all types of software. Understanding sequence decisions and loops allows you to mentally map how a program behaves, even without reading the actual code. A programmer who can visualize the path of logic using flowchart components is better equipped to design, test, and debug applications. This form of structural thinking improves efficiency and minimizes logical errors in software development. These logic structures, sequence, decision, and loop, are not exclusive to programming languages. They are found in automation scripts, system workflows, and even non-technical processes. For example, a factory workflow might use a sequence to process orders, a decision to check for defects, and a loop to keep inspecting items until all are verified. Recognizing these structures outside of programming makes them more relatable and easier to understand. Learning how these logic structures work gives you a foundation for all future programming topics. They help explain how variables are used, how data types affect decision-making, and how software responds to different inputs. Every beginner-level coding environment, whether using Python, JavaScript, or block-based tools, relies on the same logical constructs introduced by flowcharts and structured thinking. Reading a flowchart requires interpreting the symbols and following the path from the start to the end. A typical example begins with a start oval, flows into a process rectangle, encounters a decision diamond, branches based on a true or false result, and eventually ends with a stop oval. Each symbol serves a clear purpose. Process boxes show actions, decisions show logic branches, and arrows guide the overall flow. On the exam, you may be shown such a diagram and asked to identify what happens after a given decision. Sequences represent the simplest form of logic, where one action follows another without any deviation. A program that displays a welcome message, then asks for user input, and finally prints a confirmation is following a sequence. There are no choices or repeated steps, just a clear, linear path. Recognizing sequences helps clarify basic code flow, especially when no branching or loops are present. Decision logic introduces conditions into the sequence. For example, if a user's password matches the stored password, the system logs them in, otherwise it denies access. This single decision point leads to two potential paths. This type of branching appears in every programming language and forms the basis for interactive software behavior. In flowcharts, the decision diamond reflects these conditional checks and shows how a single test can redirect the program flow. Loops add repetition to program logic. Consider a program that asks the user to guess a number and keeps asking until the correct number is entered. Each incorrect guess results in the same question being repeated. This loop continues until the condition becomes false, such as when the user provides the right answer. Flowcharts represent this by looping arrows that lead back to earlier process steps, reinforcing the visual representation of repeated execution. Loops are particularly valuable when working with collections, such as arrays or lists. For example, a program might use a loop to process each item in a list of numbers, calculating totals or averages. This task would be extremely inefficient if coded as a series of separate actions. Instead, a loop allows for a general instruction to be applied to each item automatically. Understanding this use of loops connects directly to flowchart logic. Flowcharts relate directly to real programming structure because they mirror what code does. Each rectangle in a flowchart corresponds to a command in a program. Each diamond reflects an if statement or loop condition. Arrows represent the transition from one block of logic to the next. Even though the exam won't require coding, this visual to logical mapping helps you interpret how a program behaves and prepares you for understanding actual software flow. On the exam, you may encounter questions that ask you to match a symbol to its meaning. For example, a rectangle may be described, and you will be asked to identify it as a process. Other questions may present a step-by-step flow and ask which symbol would be used to represent a particular action. You might also be asked what happens after a decision leads to a false condition. These questions focus on interpreting and predicting flow behavior. The exam may also ask about the correct order of operations. You might be given a series of actions and conditions and asked how they are sequenced. Questions may ask which step comes after this, or what happens if the condition is false. Practicing how to read flow from start to finish will improve your ability to answer these types of logic sequence questions with accuracy and speed. You will not be asked to draw diagrams, use flowcharting software, or analyze nested logic paths. The exam avoids complexity in favor of recognition. You won't need to understand advanced logic such as recursion, break statements, or switch case conditions. The focus remains entirely on simple linear structures, identifying whether a path follows a sequence, contains a decision, or uses a loop. Staying focused on basic flow logic is the best preparation. There are key flow and logic terms you should memorize before the exam. These include start, process, decision, and end, as well as condition, sequence, loop, and flowchart. Understanding the meaning of true and false in relation to decision paths is also important. Boolean values determine flow direction, especially in loops and condition checks. These terms may be used directly or appear as answer choices in matching or scenario-based questions. Beyond the exam, understanding how flow works helps in debugging and interpreting actual programs. If you know how a decision affects flow, you can trace bugs or errors by following the path the code takes. Flowcharts also help in planning new features, showing how logic should progress before writing any code. In technical interviews or collaborative development environments, explaining program logic with flow-based vocabulary shows clarity of thought. Programming, at its heart, is about structure and control. Knowing how to create conditions, execute steps in a particular order, and repeat processes based on logic is essential to every application. These skills go beyond exam preparation. They shape how you approach technical problem solving. Whether you're learning Python, reviewing system scripts, or troubleshooting automation tasks, flow logic is the backbone of every process. To summarize, flowcharts and control structures help define the behavior of a program. Flowcharts use standardized symbols to show sequence, decision points, and loops. These visual tools clarify logic and prepare you for interpreting program flow. Understanding how arrows, shapes, and Boolean values guide execution gives you a practical advantage on the IT Fundamentals Plus exam and lays the groundwork for programming literacy. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.